Hey, Bogdan Brzeski here. Welcome to another video, quadratic functions consolidating all possible forms, standard form, vertex form, and factored form in one long video. So let's begin. Completing the square is the strategy that we will be utilizing here, showing how a standard form has been converted into a vertex form using very typical sort of magic steps in mathematics, in algebra, where we will be applying the zero principle. So oftentimes when you are watching proofs in mathematics, there are some tricks. And one of the mostly used trick in mathematics in algebra is the zero principle, where you insert zero by adding and subtracting the same value. So let's take a look by going over this beautiful example. So my magic pen is ready. So we starting with a standard form. Y is equal ax squared plus bx plus c. We understand that a, coefficient a, is not equal to 0. And we start the process with factoring that leading coefficient a. So when you do that, you have to compensate for terms inside. So divided by a and divided by a again. So this is why a cannot be equal to 0, because we have now a denominator in the value of a. So now the secret weapon in mathematics. At any time, you can add 0 to your expression without changing the overall value of that expression. And you can create a 0 the way you want, the way it suits the process. In this case, we are thinking about creating a perfect square trinomial, where the first term is squared, the last term is squared again, and the product, the middle term, is 2 times first times last. So if you think about b over 2a, when you multiply by x and times 2, it will be in totality b over a times x, because the 2 will be cancelled. So hence the secret 0 introduction, that we would use b over 2a squared, because we're missing the third term in the expansion of perfect square trinomial. And at the same time, you subtract that added value. So that's the 0 principle. Now, we are inside of that bracket, so we have to make sure that this change happens inside of that bracket that we started with right here. So the first 3 terms we will group and convert into a perfect square trinomial, and then convert into binomial squared. So this is x plus y outside to the power of 2, if you will, or a plus b, whichever letters that were used introducing perfect square trinomial. We did that in our previous video, so if you're not familiar, go and review that. So this is compacted beautifully, and then you would multiply a times that term, negative outside of brackets, b over 2a squared, and also in the process of a distribution, you would multiply a times c over a. So this is happening right here. And in the process, we would simplify. You always distribute, multiply, and make it simpler. So that's sort of the standard approach in algebra. When you're working with expressions, equations, you complete a step, and then you always take a look and say, can I make it simpler? Can I make it some reduction here? So a from the top and a squared from the bottom will be reduced, and beautiful setup here where you have a on top and a on the bottom. So down to the next line. So c will be part of that reduction, and this all together will give you b squared divided by 4a with negative sign in front. Now, please note that when you have collection of terms, in algebra, you can change the order and appearance. So you don't have to be saying that I must put this first and this second. You can change it. So C with positive sign, it's always more convenient to have that term followed by the negative sign. You will see in a moment why that makes sense. So far we have a leading coefficient, this beautiful binomial squared, plus something here. That something will be using common denominator, so times 4c times a to compensate for 4a common denominator. So that is why you have 4ac right here, and b squared already was over that 4a, so common denominator, bingo. So this is almost completing step. Why? Because now, if you already have seen the other video, we have introduced the vertex form of quadratic function, and it went like so. Y equals a times x minus 8h to the power of 2 plus k. So h and k represented the vertex coordinates. So if you recall that, then you can claim the following. Then you can say whatever is inside here, this is your h. So this would be minus b over 2a, equivalent to the x coordinates of the vertex of parabola. And this entire thing, negative in front of the brackets, b squared minus 4ac divided by 4a, would be equivalent or corresponds to that term k. So now we can use the standard form of the equation, and using the values of a, b, and c, we can identify the location of the vertex coordinates, so that you don't need to always know the vertex form. If it's presented, if it's given to you, that is a very convenient situation. If it's not, you can always extract the coordinates of the vertex by identifying a, b, and c's, and then knowing this new formula that becomes very handy. So vertex is equivalent to negative b over 2a, x coordinates, and negative discriminant, that portion b squared minus 4ac is called also a discriminant from quadratic equations. So let's move down to the following. From the vertex form to x-intercept. So this is the connection between the vertex form and the quadratic formula that you use very often and probably most of the time when solving any type of quadratic equation. In order to make it happen, we have to let y be equal to 0, because this is the x-intercept or root of an equation where y is equal to 0 and you intersecting x-axis. So hence the statement, if y is equal to 0, now we can create an equation. So traditionally, on the left side we have variables, on the right side we have constants, so we switch the sides. So please note that nothing changed. You have positive a, exactly the same binomial, minus this expression is equivalent to 0 on the right side. So it's sort of, this is more useful to most of us. We are familiar with that notation. So when solving and isolating for x, our goal will be to get inside of that binomial to the power of 2 somehow. Again, in mathematics, in algebra, when you're working with equations, you can separate constants from variables. You can move things around from left side to the right side by adding both sides the same, or subtracting the same quantity. You can divide both sides or multiply both sides by non-zero values. So by just separating this term from this negative term, we have now positive b squared minus 4ac divided by 4a. So that's step one. Now, in order to get inside of that binomial, we have to get rid of this term. Knowing that a is not equal to 0, we can divide both sides by a. And this is what is taking place as we speak, so that you eliminate coefficient a in front of the bracket. And now the bottom has changed from 4a to 4a squared, because you divided by a. So you multiply by 1 over a, and a times a is a squared. So hopefully this makes sense. Now, in order to get rid of this exponent, we have to undo the exponent. This is the degree 2. We will use 1 over 2 exponent, which is, in other words, square root symbol, equivalent in algebra. So we would put to the power of 1 over 2 to make exponent 1. And by doing so, we thinking of simpler expression, which is given by the square root symbol. So we would say we square both sides of the equation. So let's do that. Now, when you square root both sides, each side of the equation would result with positive or negative results. If you remember, for example, square root 9, if you want to calculate, you get plus or minus 3, right? You agree with that? So therefore, you have to account for plus or minus on the left side and plus or minus on the right side. Now, we would have 4 possibilities, both sides positive, both negative, left positive, right negative, and vice versa, left negative and right positive. So, out of 4 possible cases, only 2 would work because there will be overlap between the other 2 possibilities. So this is why we end up showing x plus b over 2a equals to plus or minus this right side. Why this is showing like that? Because next step it will reveal that we have 2 possible roots, right? So when you isolate for x, you move that b over 2a over to the right side, so that becomes negative b over 2a plus or minus the remaining portion, which also has the same denominator to a. So when you put it together, you see it like so. Negative b, this is plus or minus double operation. It tells you that one time you would add the square root, b squared minus 4ac, the other time you would subtract, and everything is divided by 2a. So this is the quadratic formula developed for you right now. And b squared minus 4ac, this is the discriminant part of the quadratic formula equation, where that determines whether you have 2 x-intercepts or 1 if it's 0. If it's negative number, no x-intercept, the parabola is entirely off the x-axis, it's either above or below. So when you want to find the average between those roots, you would add them together, and then by dividing it by 2 x-intercepts, find the average, then you have the location of the x coordinates of the vertex, you have the location of the axis of symmetry. So when you add those 2 big statements, the square root b squared minus 4ac canceled each other out because you have negative, the other time you have positive, so that's 0. So you end up with 2b over 2a with negative sign in front. Divided by 2, it simplifies to negative b over 2a. So now you see why the x-intercepts added together would generate the location of axis of symmetry. And this is the x coordinates of the vertex for that parabola. Roots in factored form. Now we will be working with roots because we have a formula for each root and we define a product. So this is related to factoring method of trinomials to the power of 2. Also, this is related to Vieta's theorem that was discussed in another video. So when you define a product of these two roots, you have like a difference of squares application, because you can do the long way, but we have negative b plus the square root times negative b, which is identical, minus the square root b squared minus 4ac, which is application of difference of squares. If you remember seeing it, if you're not, you watch other videos when we talked about it. So this can be quickly resolved into x squared minus y squared. So instead of doing the long method of the FOIL, expanding everything, which you could, you would quickly use the difference of squares. When you raise to the power of 2 square root, you eliminate the square root, and then b squared and b squared will be gone, and then boom, you have 4ac on top divided by 4a squared, because you multiply 2a's times 2a's, and that is reduced to c over a. We know from the previous slide that the sum is negative b over a, so now this is the sum of roots, and this is the product of roots of quadratic equation. So let's recall the factored form. You've seen it already. So coefficient a is at the front, and you have x minus root 1 times x minus root 2. If you choose to expand, to multiply it together, you're going to keep the coefficient a entirely factored out. You would have x squared and then 2 terms with negative p and negative q x added together. So you can pull out those the x as a common factor, and the last negative p times negative q would give you positive pq. So when you expand, you will get this trinomial. Now, p plus q represents the sum of roots. So this is replaced with negative b over a, and the product p plus q is replaced with c over a. So simplify a, and a is gone right here as well, and all of a sudden you back to the standard form of that quadratic function. So everything now it's connected. You can see that we can convert, factor it into expanded form, factor it into standard form, and factor it into vertex, and standard vertex, vertex into standard. Everything can be now finally quickly converted. Each form is equivalent, and no matter what form you have, you can still solve for location of the vertex, location of the axis of symmetry. You can identify x-intercepts, how many, 2, 1, or none. Everything now becoming clear and beautifully tied together. So, example. So let's start with a nice example where you have standard form with fractions. So that sort of makes you feel a little bit uneasy, but it's okay, because when you are able to do those challenging, difficult questions, you can knock out any questions on your test or final exam. So first thing, if you want to find vertex of the coordinates of the vertex for this particular case, you would take out coefficient a. You remember how we developed the formula, and you add a 0. Now, when you take out 2 over 3 from that, obviously you have 1x squared. When you take out 2 over 3, you divide, right? So you get negative 2, because if you choose to multiply negative 2 times 2 over 3, you get negative 4 over 3. So hopefully this makes sense, how you create that. And then 16, when you divide by 2 over 3, you get negative 24. So remember how to work with fractions. We talked about fractions, other videos in depth. So please go over that if you need some refreshing skills. So your 0 now, thinking of the perfect square trinomial, you have first term, you have middle term. So the second term squared is 1. Why is that? Because 1 times 2 times x gives you that beautiful middle term. So 2 divided by 1 will give you 1. And technically, this is negative 2 divided by 2. And then when you square negative 1, you get 1. So you're inserting 0 as 1 minus 1. You group the first 3, and you have a perfect square trinomial. And then inside of brackets, you work out with the rest. So this is negative 1 and negative 24, negative 25. So this is almost the perfect final statement, but we're not there yet. So be patient. 2 over 3, you would multiply by negative 25 to fully expand it and show that vertex form. So this is a long way of doing things, and I understand sometimes it's very confusing for you. So right here, I'm going to share you sort of the secret how to do it fast without sweating too much. Now, you already know that without using this vertex form, you can identify coordinates of the vertex by using this formula that was already shared with you. So that's another tool that you already have. Or in case you get stuck, please remember that every time you work with parabola, you have a symmetry in the line axis of symmetry. So you can cross it with any horizontal line, and then by finding interception, you would find a vertex as the average between those points of intersection. So we would, every time you have a standard form of equation, instead of doing the completing the square, you can allow y value to be identical with that constant c. So this is why you see negative 16 is equal to negative 16 on both sides. So the benefit of that is that you can immediately reduce this long equation into 2 terms equations, which is very easy to work with, because now you just take out the common factor. You don't care about whether you have fractions or not. Take out just x and then solve it for 0, right? Because when negative 16 went away from the left side, now it is 0. So product is equal to 0 rule. So which means 1 factor is 0 because x is equal to 0, or you're solving for x the second factor, which is 2 over 3x minus 4 over 3. So make it equal, and then divide it both sides by 2 over 3, or multiply by 3 over 2. And you see it's not hard to identify the result that x is equal to 2. So now we have 0 and 2. And when you find the average, this is the location of the axis of symmetry. This is the location of the x coordinates of the vertex, and we know it does work. We already know it is 1. We have it right here. So how do you find the second y coordinates? You put back quickly into that equation, any equation. You can use this, you can use that, and then you identify the y coordinates, bingo. So hopefully that method also would work for you, or maybe you find it easier. I find it myself quicker than going through the process of changing into a vertex form, which is very time consuming. And let's see how that works on the graph. Now you have this equation graphed by Desmos. You would change to a vertex form, and you would see that this is identical. If you were to multiply by 2 over 3, you would get, equivalent parabola. We know that x-intercepts here is negative 4 and positive 6. So that confirms that the average between negative 4 and 6 is equal to 1. So that's the direction of the line of axis of symmetry. X is equal to 1. That's the location of the vertex of x coordinate. This is the horizontal line, y is equal to 0. So this is the line where you find intersection with parabola. Right in between negative 4 and positive 6, there is an axis of symmetry. There is a location of your vertex. If you do the same thing using the symmetry of the graph, if you ran horizontal line through y-intercept, where y is equal to -16, you will see that you're intersecting the graph at 0 and at 2. When you add 0 plus 2 and average that, you get 1. So anywhere you would draw a horizontal line cutting through parabola, those 2 points of intersection, when added, divided by 2, will give you always 1, because it must. It is a symmetry line that passes through the vertex, so it doesn't matter where you cut it, but the convenient way for us always is to cut through the y-intercept, so that we can reduce the trinomial. If you eliminate 16, you can reduce that and find x solutions very quickly through factoring, and then finding the average. You have your vertex location, bingo. So hopefully this makes sense. Now you have the skills, how to work with standard, factored form, or a vertex form of the parabolic equation, of the quadratic functions, and then you do your practice questions to further master your skills. Share this video with your friends. Ask any questions in the comments below. We will see you next time.